So how does via impedance impact signal integrity? If the via impedance does not match the transmission line impedance, the signals passing through the via may reflect back. So the magnitude of this reflection depends on the difference between the impedance of the trace and impedance of the via at the transition point. So to reduce impedance discontinuity, implement a coaxial via structure where the signal pad at the center is surrounded by multiple ground vias. And then, of course, try our via impedance calculator to render accurate via capacitance, inductance, and impedance using its physical dimensions. So and manage your via stubs to avoid signal attenuation as well. So a via stub is an inactive portion of a via that forms a resonant circuit with a specific frequency. So when a signal operates at this frequency or at its odd harmonics, it can cause the signal attenuation. So to avoid this, make sure the signal's maximum frequency is significantly lower than the stub resonant frequency. And you can always adapt backdrilling to eliminate the via stubs. So going through some DFM tips for backdrilling. So backdrill diameter should be slightly larger than the primary drill diameter. And so the diameter is usually 8 mils over the primary drill size with a 3 mil tolerance. So provide a minimum 10 mil trace and plane clearance from the back drill. Don't forget that. And then a maximum of 10 mil stub length can be retained after the back drill without significantly affecting signal integrity. But really, we can get very accurate with the back drills now. They can stop within 1 mil of the copper layer without penetrating the copper layer. So you can get, based on your layout, you can get specific design rules from us.